my channel. Welcome, welcome.
Hello students, let's start discussing some important derivations from rotational dynamics class 12 HSC board physics. So here today we will see about the horizontal circular motion. I classify this in two types, like unbanked horizontal circular track and a banked horizontal circular track. It will just simplifies your job to remember or to learn these topics or the important derivations based on these topics. So first it comes, let us see, unbanked horizontal circular track. Again I divide it in two parts. First it contains the derivation about if vehicle is taking a turn on a horizontal circular road, and the second part it includes if the vehicle being driven in a horizontal circle in vale of death, or sometimes it is asked if it is being driven on a wall of death. And the second part, second type of this horizontal circular motion is if the vehicle is driven on a banked horizontal circular track. See, this is get classified, I like in this way, like maximum safe speed we want to find out on a banked road but neglecting friction, and the second it contains safe speed for a vehicle if it is driven on a banked road, but here we will consider the friction between the road surface and the tires of a vehicle. Okay, so now here let us start with this. Now vehicle, when it takes a turn on a horizontal circular road, what we have is this, a diagram in a way that you will have to remember is this. Now see, in these videos we are doing a fast recap of the concept, so I am not going in detail, so we will do a derivation part only over here. Here the diagrams which are important for your board exams, so I am referring a textbook over here. And now let us draw the diagram. If this is the vehicle, and just do remember in the board exam, in the paper, in the answer paper, you are supposed to draw the diagrams by pencil only. At any cost, please do not use the pens to draw the figures only because it simplifies your jobs. No, it's not giving you any kind of marks. So let us say this is C, stands for center of circular track. Let this be the center of mass of the car which is being driven on that horizontal circular track. Obviously, its weight mg is acting in vertically downward direction. As we all know, the road surface will exert the normal reaction on the car, and all the forces we know those are acting at the center of mass. So here this is being the normal reaction, and this is the weight of the car acting in vertically downward direction. So let's draw this, and what this arrow represent the force of friction. Now this is the radius of that circular track. Okay, so for the mathematical part, see, this is the description, and here in the description you are supposed to add, consider a car of mass m being mass of the car, mass of a vehicle which is driven, which is moving on that horizontal track, r be the radius of circular track, Okay, so this is kind of a descriptive paragraph you are supposed to write in the derivation part after just completing the figure. So now the mathematical parts, the mathematical core parts comes over here. What we see from figure is the of the car, weight of a vehicle is is balanced by normal reaction. So here we have N is equal to mg. And the second part here, if you observe, this force of friction is being in the direction of the or direction towards the center of a circular track and is along the radius. Here we can say the centripetal force necessary centripetal force is provided by force of friction Fs. Force of friction Fs. So what we have here, another equation, Fs is equal to mv square by r. Now let us give the number to these equations. N is equal to mg. Let's call this as equation 1. Fs is equal to mv square by r as equation 2. Now we all know that by theory Fs is given by mu Sn, where mu s is what? Coefficient of friction. Coefficient of friction. So if we substitute this value of Fs in equation 2, what we get is mu Sn is equal to mv square by r. Now, from equation 1, what we have is about n. So, let's substitute that from equation 1. We get mu s instead of n, we will be putting mg, which is equal to mv square by r. Now, in this topic, what we are supposed to find out? We are finding out the minimum safety speed with which the car can be driven safely on that horizontal circular road. So, let's arrange this equation for V. So, here we get mu s r g as V square, and therefore under root mu s r g give us the necessary formula, which is the maximum safety speed with which the car or any vehicle can be driven safely in horizontal or on horizontal circular track. Yes. Now the second one, about the second one. The second derivation in this part is vehicle being driven in horizontal circles in a vale of death. So let's draw the figure for that. Let's draw the nice one. Yes. Consider this is the vale of death, or you can say the wall of death, along which that motorcyclist is driving his bike. So let us say this is the dotted circle represent the circle along which that motorcyclist is driving his bike. Now this is the radius of that circular track along which that biker is driving his bike. So as we know here, now here we are considering the motorcyclist is being represented as a point mass like this. So its weight naturally is acting in vertically downward direction just to avoid the slipping in vertically downward direction. There is a force of friction comes into picture which obviously act in a vertically upward direction. Also we know this is the road surface, this is the curved road surface along which the motorcyclist is driving his driving his bike. So as we know, the normal reaction is exerted on the biker from the road surface or by that road surface. So this is now the horizontal arrow represents the normal reaction experienced by that motorcyclist. So what we have in over here, again here I just do suggest you write the paragraph that describes this figure in your own words. This is a necessary, a must taking a step while scoring the marks in board exam. Yeah. So here again, if I just do write M or mg is a weight of motorcyclist. See, sometimes in the exam, you may find the question that they include the weight of a motorcyclist along with its bike. So whatever it is given, mg represents the weight acting vertically downward, acting vertically downward, and fs represent the force of friction acting vertically upward just to avoid acting vertically upward to avoid downward slipping of the bike. Of bike. Okay, so from the figure here we know that Fs is balancing mg. Let's call this as equation 1. Also, from that figure we know as n is a normal reaction exerted by road surface or that wall surface you can say on a biker, of course along with its bike, and as it is directed towards the center along the radius, here we have n is equal to the necessary centripetal force. N is equal to mv square by r. So this is another equation that we get that you are supposed to remember while writing the answer for this question. Okay. So now also one more point from theory. By theory, we know since Fs is always either less than or equal to mu Sn. Therefore, what we have, Fs is less than or equal to mu Sn. Therefore, substituting the values, substituting the values of Fs and N from equations 1 and 2. What we get is Fs is mg from that equation 1. So we'll write mg, which is less than or equal to mu s, which is representing coefficient of friction, and n is mv square by r. So here we see m get cut, so it remains Rg, which is less than or equal to mu s times v square, or Rg by mu s is less than equal to v square, and that just we are arriving at our required formula or the equation about which we are writing this derivation, that is v under root Rg by mu s. Rg by mu s. So this is it. These are another two important derivations regarding the vehicle if it is being driven on the curved surface of vale of death or wall of death. Okay. Now here let us do one more a short derivation which is much more simpler. Now if what happens, and this is about a banked road, yeah, what happens if just to if I want or if anyone wants to drive his vehicle with a greater speed, not too much, with a greater speed which is more than v is equal to under root mu s r g. This is the maximum safety speed for a horizontal track. And if someone wants to drive his vehicle or her vehicle greater than this speed, then to have a safety, the road being get banked. Let us derive the derivation of maximum safe speed on a banked road. But here for this part, we are neglecting the friction. Okay. So now this is also being called as maximum safe speed on unbanked road. So just skipping all the information about why there is a necessary of banking of roads, because here we are just going to discuss the important derivation part and not the entire theory. So let's begin with that. So first it comes the figure for a banked road. The figure is something like this. Figure is like this. This is the elevation given to that road to have a more safety if there is a vehicle is driven with a higher speed than the under root mu r g, that speed. Okay, so angle of elevation or angle of banking is given to be theta, and as the vehicle is now driven on this banked road, let's complete the figure. This is the center of mass. Now all we know is the weight always acts in vertically downward direction. So this arrow represents the weight of the car. Now perpendicular to the road surface, there exists a normal reaction, or the road will exert a normal reaction on that car which is being driven on that banked road. So to see which component of this force is providing the necessary centripetal force, for that purpose we will just resolve this normal reaction in two components like this, one along the radius and one along the line of weight mg, along the line of weight mg. Yeah, that's it. Now we see this is again, by doing the geometry we come to know this angle is also theta. So this one is the adjacent side, this component becomes n cos theta, and this another one will obviously n sin theta. So here for this what we have is n cos theta. The mathematical part I am writing. Of course, before this, you are supposed to write the paragraph which is describing the figure, and that is a necessary. N cos theta is the component of normal reaction which is balancing the weight of that vehicle. So let's call this as equation 1. And n sin theta is directed towards the center and is along the radius of that circular track which is now banked. So this the component which is providing the necessary centripetal force. So here we have n sin theta is acting or is providing us like mv square by r, that is a necessary centripetal force. Yes, we want to find out the formula or the equation or the expression for V, the speed with which the vehicle can be safely driven now but on banked road. And here we are neglecting the friction. So taking, or I do like to write, dividing equation 2 by equation 1, we get we get let's see what we have. N sin theta by n cos theta, which is equal to m v square by r getting divided by mg. So here we'll come to know that n get cancel out, m also cancel out. Now sin theta by cos theta, as we know, is tan of theta. So tan theta is equal to v square by rg. Rearrange the factors to get the value of v square. So we have v square equal to r g tan theta. Now for the v, we have to take the square root on both sides. So under root r g tan of theta is equal to v, and this is the necessary expression that we are finding out for the speed, for the safest speed with which any vehicle can be safely driven on that banked road. Now, if you observe the formula here, it does not include the mass of the vehicle, since this expression does not include mass m of a vehicle, mass m of a vehicle, the maximum safest speed will be same for all vehicles, ignoring whatever will be their mass vehicles. It is, in other words, you can say that maximum safety speed on a banked road is independent of mass of a vehicle. Yeah, that's it. So here today we will stop, and in the next video, in the next lecture, which I will just upload on a next Monday, next coming Monday. So there we will see the another further derivations that we have written, that the maximum safety speed on a banked road, but now considering frictions. So if you like my video, do share this with your friends which need the derivations to be learned in simple language. So do share, like and subscribe my video and my channel Knowledge Lane. Thank you.